Welcome back. Recently I acquired this 8-inch Schmidt-Cassegrain telescope. A lot of you who follow my channel are into the Mac Casses. You probably love them about as much as I do, which is really probably my favorite optical design out of all telescopes. Recently, a friend gave me this, and a little disclaimer here, this telescope was a C8, basically a Nexstar 8SE with the Star Bright Coatings logo and all that jazz. It came off of the Altaz mount. There was one stipulation with this gift, and that was to remove all evidence of it being a Celestron product. I don't want to get into who told me that or why. It's just something I had to do. So yeah, I got rid of the logo here. As you can see, it had a Star Bright coating sticker, the orange tube that's pretty common, but that's a little hard to get rid of there. Cut it out, put some solar filter or something. But anyway, I'm pretty much done dumping money into this optical tube. So I realize a lot of people love the SCTs. This being the 8-inch version is pretty popular. So in this video, I really want to talk about not so much focused on the SCT as a review as much as it's a comparison to the Mac Casses that I'm used to using. So I've put this thing up to planetary deep sky, ran it through the paces, and I've made quite a few internal improvements to it, which I'll get into. So basically the design on the internals of this thing are very disappointing. I don't know how else to say it. I have seen inside the older orange tube C8s, and they were made a lot different than this. I can show you pictures. The mass production of these things has gotten a little out of hand. As I said, I know a lot of people love SCTs. It's not for me, and I want to tell you why in this video. So it's kind of, if you love them, then there's no real reason to watch this. But for somebody who's looking to increase their aperture, and say you have a 127 Mac or the 90 or something like that, you do a lot of planetary, especially. You think aperture, you think detail, which would be true. But it comes with so many things that for me were just annoyances that I can live without. So I think it's useful information. So we'll go into gutting this thing and what I have to do, my experience using it, and some examples and that sort of thing, and a little bit about location and why that's important, on whether or not you have this design telescope. And hopefully it'll be an interesting video. So thanks for watching ahead of time, and it's not going to be a very friendly review, but here we go. So if you have an SCT like this, the very first thing that I can recommend as far as an upgrade would be these collimation knobs. Ooh, look at the smudges on the mirror. Terrible. Who cares? But as a stock, the newer one has the Phillips head screws. So you're forced to, a lot of times in the dark, have to put a screwdriver down into the tube to collimate this thing, and that's not a very fun experience. So I got the Bob's knobs. I'll leave a link to the exact ones you need for the 8SE. Now apparently that's different with the older C8s and stuff. They had a little different screws here, but anyway, having these is probably the best upgrade you can make, because you will have to collimate these things. They do get out of collimation easy. I've read reviews, mixed opinions. I can tell you from personal experience that it was something I had to do every time I moved it. Like if I took it outside. So that's one point I want to make. As an observatory telescope, it probably functions really well. But for something that you have to run out in the yard with, if you have to pick this up physically, even you treat it like a baby, put it on the mount, and you're ready to image, you will have to collimate it. So something to consider is, and that's why these are so important, because instead of fidgeting with a screwdriver and standing the chance of, you know, poking the glass of the corrector plate, you can use these knobs, and that's a whole lot better. As you can see, there's the Vixen rail that came with this, and it's perfectly fine. It's functional, but if you look at the top here, and actually I got it covered because I had a portable battery here for a USB dew strap, but there's a couple of spots. Farpoint has a really good Lost Mandy plate, and it allows you to turn the telescope this way. It puts the focuser on the left, which is really no big deal, but it gives you a whole lot more mounting options and gives you a lot sturdier platform to put it on. I feel like an 8-inch telescope should be on a Lost Mandy. That's just my opinion. It's definitely more rugged. As far as focusing the SCT, very big pitfall here. As you focus the telescope, you get image shift in it. It's basically just the mirror wobbling around inside of the system. You say, well, that's no big deal. It'll come to rest. But for 2032 millimeters, and probably something you have a Barlow on for planetary, so you finally get Jupiter focused or centered up in the frame, and then you try to focus in, and next thing you know, it's way over here. That is a super pain that you don't deal with the Maksutov design. Well, I take that back. The Meade ETXs were pretty bad about that, but you could correct for that pretty easy. With this SCT, I'm going to say, like, say you were on just a motorized mount, for example, it would be a nightmare trying to get your planetary imaging done. A lot of times you'll start at a higher gain just so you can find it, and then once you locate the planet, and you try to lower your gain and find focus, and then it's hopping all over the place. So that is I've heard that was the case with SCTs, but I didn't realize just how bad it was. It's really terrible. It might be slightly different in different units. It could be better in some and not as good in others. But so after a week's worth of all the different experiences I had with this one, I took it and broke it down. I did take it apart completely, and that's when I discovered some serious flaws with this design, and I improved it quite a bit to where it's a whole lot more functional. I'll show you what I did, and maybe it's something useful for you if you own this telescope. So that brings me to my second and extremely crucial upgrade would be to add an external focuser to these things. And in that way you could do your crude focusing with the main focuser on the system, and then get fine focus with the external focuser. A lot of people do that. It's in fact why there are mirror locks installed on like the Edge series. It's just to prevent some of this mirror tilting that's so bad in SCTs. And it's just something to consider. That's an extra expense. If you cheap out on a focuser, you're going to have issues that are inherent with that. So again, you're looking at spending, I'm going to say at a minimum, around $400 to get something halfway decent. As it was, for me personally, it was a nightmare. If I came into astronomy with the SCT as my first telescope, I probably wouldn't know better. But like I said, this review is about Maksutov's SCTs. Having used so many Maksutov Cassegrains, it's just unacceptable for me. It's to the point of you already have enough struggle per se with a high focal ratio of trying to get, like, say you're doing planetary nebula and that sort of thing. So you've stepped up the Mac game from solar system to deep sky. Typically the brighter planetary nebula and stuff is what you'll be targeting. Ring Nebula is a good example. Go to Astro bin and check that out. Quite a few Macs have been put up to that task. But that being said, this is a whole different ball game. If it was my first telescope, and I would just adapt to it and probably not complain about it, but because I've been spoiled by the Maksutov, the things I don't like about this are really bad. So the focus shift, I've mitigated quite a bit. I'll tell you how. And there's the cooldown, which it's not quite as bad as the Maksutov, I don't think, but it still exists. So most all of my planetary work I do on my 5-inch 127 millimeter Maksutov, which I really love. And I know that that's a very low, very small aperture for planetary. It's just something I enjoy. But a keynote on that is that I live in eastern North Carolina in the United States, and the humidity here is often like close to 100%, and it's usually really poor seeing. In fact, the company Lunt sells solar scopes. They have what they call the coastal package, and that's for people who live close to the water. It's really difficult to get stable columns of air. So in defense ahead of time of the 8-inch SCT, I can say that with the larger aperture and the longer focal length, you know, your column of air has to be more stable for this to get a good clear image. So I did image over multiple nights and did the best I could with my area. It's also why I love the 127 Max so much, because it is very forgiving. So people who have inclement weather, as I do, a lot of humidity, that sort of thing, a lot of turbulence in the air, the 127 is very forgiving, even at its focal length of over 1,500 millimeters. But that being said, my initial response prior to using this was 8 inches. Wow, yes, because I have to make the jump, because everybody will, where they're curious, like, what's it going to be like to go from 5 inches to 8 inches, or from, you know, whatever it is that you're using. Typically, when you think planetary and you think bang for buck, you got kind of two options. You can go with a large Dobsonian or a reflector type telescope, or you move to the SCTs, because 8 inches up, they're relatively inexpensive compared to large refractors, that sort of thing. So that was my interest, like, what can I do with it? And I'm kind of disappointed, because aside from the obvious difference in light gather, because this is an 8-inch aperture, 8 inches should completely blow away the 5-inch Maksutov. If you hear a lot of click, 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 it's my dog, sorry. That's it's Renzo. He's just interested in what I'm doing. But anyway, so how big of a difference is 8 inches to 5 inches? And it's really negligible in my opinion. And I'll show you that. One of the key things here, if you look at the center obstruction of the SCTs, it's relatively large. That's the reason the contrast is it's kind of knocked down like it is in a reflector. But it's also the reason that even though this is 8 inches, it's not really performing as an 8-inch instrument solely. It wasn't too big of a factor, but the main problem with this over a Maksutov, and I'll tell you, for everybody who loves the Matcasses, you're probably at this point, you're spoiled rotten with collimation. I could just about throw mine against the wall without losing it, and with this, it's every single use. I mean, just me tapping on that, probably throw it off. It's something you got to live with. I know it's like boo-hoo, you know, oh, he has to collimate. It's just one more thing you have to deal with, you know. Now, that being said, as you know, these are also very versatile telescopes. So you can, a good video series to watch would probably be Astro Blender. And to confirm how good of an image can be done with these things, I would refer to Chuck's astrophotography, because he's done some amazing things with this very telescope, the 8-inch SCT. And people put the f6.3 reducers on them, which brings it from an f10 instrument to an f6.3, and drops the focal length of it quite a bit, gives you a wider field of view, and use them quite often for deep sky. In my deep sky setup, I actually just used the native focal length because I wanted to really get a feel for the optics without any interference, so to speak. The Antares reducer I have, I didn't want it to play a role in my decision making on excuse me, on image quality. So I did the difficult thing of shooting this at its native focal length, and that's no picnic, because for one, I should have used an off-axis guider or mounted a ST80 or something like that, but I just ran with what I had available quickly, and that was the Orion 162 millimeter mini helical guide scope, which it did a fair job. It's not something that you would build this system on anyway with any reliance, but regardless, yeah, so over the Maksutov, it has the flexibility of being easily reduced, and it has a rather large exit hole for the out the back. So if you know the Maksutovs, even the ones that are advertised with the 2-inch SCT backs, you're not really getting the full 2 inches. Check out Martin's video and he'll show you the measurements and all, but the Maksutov has a much smaller exit hole here. So there's to some degree vignetting and that sort of thing that occurs when you try to reduce them and do flexible things with them like that. But it is, like a Maksutov, it is a spherical mirror. Now the corrector, it appears to be flat, but it's technically not flat. There is a polish to it, and it's, I mean, fairly similar, except for that it has a floating secondary in there that the light bounces off of, reflects off of, whereas the Maksutov it's got the concave corrector, and then it, excuse me, and it has the optical surface on the back of the actual corrector. So that makes it a whole lot easier to collimate, because you know, you're dealing with a spherical mirror. My initial impression of deep sky with this was that I should have reduced it. If you are going to use it at its native focal length, then you're going to have to invest a little more money in it and that sort of thing, or use an off-axis guider most likely, or a larger guide scope. And it's pretty much at that point going to be good for the same kind of targets that your Maksutov would be anyway, with the exception of it's f10, so quite a bit more light. It's a faster telescope. And also, back to that, there's not as much vignetting when you reduce it, that sort of thing. So it has purposes and functions that are highly flexible as opposed to the Maksutov. But for me personally, they're not worth the headache that comes with it. And that's my overall opinion on the system as a whole. I don't see it changing no matter how many times I use it. In fact, I really don't want to do what I feel would be wasting a clear night on this system again. Like, that's probably the last time I'll use it. And ultimately, if you're looking for the answer, so where do I go for higher detailed images of planets and that sort of thing, I would definitely go to the 180 Maksutov before I would buy a C11, C14, any of that. Back to my location again, I don't think that my skies would support a C11 or a C14. I don't think I have, I mean, in other words, I'm magnifying an already bad atmosphere to the point where it's unusable. 8 inches is actually very close to that number for me. But the 7-inch 180 Maksutovs, that's the way I would go. So if you're coming to this video from my channel, what's your overall opinion? I'm interested. I've heard some of you say that. Definitely not the SCT. In terms of just optical quality, I would say it's a little soft. I don't know what I can attribute that to. I've been very careful with my collimation of this thing, to the point of actually reseating the corrector itself with equal distance using feeler gauges and that sort of thing. I mean, I've been spot on with that. And even checking the rotation of it, that sort of thing. I mean, before you start throwing that at me, I have been the full gambit on this instrument. So very, what I call low contrast. But as you know, again, revert back to the Maksutov design, it has apo-like contrast. The SCT does not. So that's something you're immediately going to notice when you make the jump is the lower contrast. And I just can't get this thing as sharp as I want it. Doesn't matter how stable the night is. I'll show you a few video clips of just how good the air was where I live. I wasted probably one of the best nights I'll see this time of year for the next several months on running tests on this guy, and whereas I should have been doing something else that I enjoyed a lot more, unfortunately. But it was a learning experience. I'm glad I came to the conclusion, because I was really close to jumping on the 9 1/4, or quite possibly even the C11, and I'm really glad I didn't invest money into it. For me personally, that would have been a really bad decision. Would I enjoy this more if it was an observatory-based telescope? Yes. I don't feel like I would have to fidget with the collimation quite as much, but I still would prefer the 180 Mac over this. It's just too fickle for my taste. There's too much babying going on with this particular telescope design. And that's the main reason for this video. So you can see how bad this area disc is. This is a typical night here in eastern North Carolina. This is about what I see normally. Here's the SCT at 254 power. I use this water tower behind my house a lot as an example, and you can see about what it's like visually looking through an SCT. And at the distance, I'm just starting to make out detail on these turkey vultures that are roosted up on top of the water tower. As you can see, there's a little bit of heat over the distance, radiant heat, so there's a little bit of blur there, but it's pretty good resolution overall for a daytime test. You can see right much. Just to give you an example there. Seriously, man, like, what the kind of grease is this? Look at, this is what they use on a focuser. And this is spray foam. It's flexible. It's got like some, like, what? So there's that monstrosity. And like, I get this, like, this totally makes sense, like how this is, the mirror, the corrector is held in place, but cardboard? Like, really? They have absolutely no pride in anything they build anymore. They just want to build as many as they can and as fast as they can. But okay, so basically this bearing, it'll free spin from the center point there, and it sets in here like this. And what should be happening is that the threaded part on the travel is pulling tension against that way, like that. But what happens is it gets loose and it starts, instead of riding against that plate, it's doing this number like this. So as the scope actually turns an axis under the weight of the mirror, is forcing the focuser, which in turn is the whole mirror itself is tilting just slightly, ever so slightly. That's why guys like Martin Pyott, they collimate to each particular part of the sky, because an SCT has got, to some degree, a little bit of movement in the primary mirror. So, shopping list: brake clean, wheel bearing grease, white lithium grease for the focuser, and a little bit of hardware stuff. And that piece of cork, I'm gonna cut out the spacers with that, and I am going to replace that foam with something that's a little bit more suitable for a fine optical instrument, and lots of paint stripper and some metallic paint. So what I'm talking about is that black ring around the bottom. It could just be cosmetic, it could be glued. That's not something I really need to be yanking on without knowing for sure whether it just slides down or if it threads off. If it threads off, there's a lot of things I can do here. You see that gap around it? That's a good indication that it's not tight to start with, and it should be pretty snug, because that, as this moves up and down, that's keeping pressure against the mirror on the shaft, and it'll reduce a little bit of wobble. you don't even need like a 1/10 of a degree with this kind of thing. So that's an improvement that I need to research and find out before I move forward with it. But you see, like, that's your focuser at the bottom. And the very nature of this is weak because it's not pushing to the center. It's pushing against one side of the mirror. So unless everything is mechanically like tolerant to like a very small fraction of a degree, then there's going to be some degree of tilt that happens. And having that collar tight is going to eliminate a lot of that focus shift, that mirror tilt. So I need to find out that before I move any further. This on an ETX, it has spanner wrench keyholes. This one does not. So I'm just scared that it's not actually a threaded collar, that it's probably just glued on there or something. They did everything else so chintzy, it's kind of hard to say, you know, for sure. These holes, if I cut that and then put some threaded rod in there with like a little bushing on it, then you could focus the mirror so it slides up and down to the focus position, and then you should be able to lock it by running those 2 threaded rods up. So I might do that. So like this lip is where the metal tube sets around this, where it's bolted in. There's a ton of room around here for like a dew strip band. You know, how cool would that be? And just put like some vents on the sides, like here and here or something. I mean, how cool would that be? I'm really seriously considering like modding that out. So this is your focuser. There's 2 bearings with a spacer. Sets in here like this. And the problem is this movement right here. Now, if you look at the back side of this, you would think that this notch would be the size of those bearings to where it's seated better than it does. And there's a little bit of slop there. Okay, I'm just going to illustrate my point. I've got another washer that I installed in here, and mind you, I just cleaned these bearings up. There's absolutely no grease in them. Like, anyway, that is essentially a little bit taller when it goes in. Okay, so here it is installed with this plate pushing against the bearing, the front bearing, like it's supposed to be. And as you can see, I can't move that at all in any direction. And it totally free spins with no grease. I'm gonna put grease in it obviously, but you see how much more effective that is? So here's a quick look at my deep sky setup for the 8SE, or the 8-inch Cassegrain at this point. Just using the ASI Air Plus, the autofocuser, 120 with the 162 guide scope. Here's just a live view of the moon from the Air Plus. Not impressive to me at all, and not as sharp or clear as the Mac. And this is consistent too. This is not just a one-shot go. This is over many nights. So here you can see the out of focus. This is a relatively good night. This is exceptional seeing for my location when it appears this way. I had several nights like this. Here it is set up for planetary. So here's just a simple, I believe it was just under 2-hour integration in HA RGB. And a little note, through a meridian flip, I had lost collimation due to the mirror shifting under its own weight. So again, there's that issue again. Again, my final thought is that I would rather have a refractor or something a little wider field with a lot less hiccups involved, and just retain the SCT as a planetary scope. And that being said, it makes more sense for me to go with the 180 Mac. And in terms of contrast and image quality, I feel like the Mac is superior. I'm not alone in that. And that's just my overall take on it. I won't be using it again, and I wouldn't purchase one in the future. So that's where it stands. And I really appreciate you taking the time to watch this. I hope it was helpful. Again, thanks for watching, and I appreciate all of you. As always, clear skies.
We can sleep under the stars, under the stars.